You're surrounded by it every time you step near the water, yet you've never felt it the way fish do. They sense vibrations long before danger arrives, reading the world as if it were whispering secrets directly into their skin. This hidden perception begins with a biological superpower called the lateral line, a structure woven like a sensory net across their bodies. It allows them to detect tiny pressure changes, even from predators too silent for human ears. This sense is so refined that a fish can feel a single drop of water hitting the surface meters away. And just when you think that sounds impressive, it gets even stranger. This system doesn't rely on sight, sound, or touch-only raw physics translated into instinct. It's the closest thing nature has to extrasensory perception. And the next time you watch a fish dart away, before you even blink, remember, it already knew you were coming. The lateral line is built from tiny organs called neuromasts, and each one works like a microscopic motion detector. These neuromasts contain hair cells similar to the ones in your inner ear, except fish use them externally. When the water shifts, bends, or ripples, those hair cells sway and send precise electrical signals straight to the brain. It's like having a sixth sense constantly scanning the environment for threats. Even subtle currents carry meaning, direction, velocity, and the signature of whatever made the disturbance. A cruising predator sends low-frequency pulses through the water. A fleeing prey creates sharper, frantic vibrations. Fish decode all of it without thinking, like reading Braille written in liquid motion. This sensory web is always active, even in pitch-black darkness. Imagine being able to sense something approaching from behind without turning your head. Fish do this effortlessly, thanks to the lateral line stretching from their skulls to their tails. It's a surveillance system woven into their skin, always alert and impossible to turn off. When a predator rushes in, the pressure wave hits the fish before the attacker does. That instant warning triggers lightning-fast escape reflexes. The fish doesn't need to see the danger, it feels the water deform around its body. That's why they seem impossible to catch barehanded. The second your hand moves, the water tells them everything they need to know. Humans rely on sight and sound, but fish rely on the water itself as a messenger. Even schooling behavior, one of the great wonders of underwater life, is powered by this sixth sense. Fish in a school move with uncanny precision, turning as one organism. They're not following a leader, they're reading the pressure waves from their neighbors. Each fish feels the wake of the others and adjusts instantly. That's why entire schools can split around an obstacle without losing formation. It's a living physics simulation, updated every fraction of a second. Sight alone would never be fast enough for such coordination, but the lateral line gives them real-time feedback loops. This is why a school can react to a predator's strike in perfect unison. Deep in murky rivers or night-black lakes, fish rely even more on this hidden sense. Where light fails, pressure and vibration become the dominant language. Catfish, for example, can navigate cluttered environments without bumping into debris. They sense obstacles through the way water flows around them. Every rock, log, and crevice alters the pressure field, and the fish interprets this invisible map with astonishing accuracy. In complete darkness, it still moves with confidence and precision. This sixth sense turns the unknown into the familiar. For fish, darkness is never truly dark. Predators exploit this sense for attack as well as defense. Pike, barracuda, and other ambush hunters use the lateral line to detect prey even when hidden. They can sense the faint water motions from a struggling fish minutes before they see it. That early warning prepares them to strike with explosive force. Their bodies stiffen, their muscles load, and their senses sharpen. They track the vibrations with pinpoint focus. When the moment comes, the predator bursts forward with deadly accuracy. Sight only confirms what the lateral line already told them. This makes them silent, invisible hunters of the dark water. But prey species are no less impressive. Minnows, shiners, and smaller fish use the lateral line as a panic radar. The moment a predator displaces the water too sharply, their reflex arcs activate. They whip their bodies sideways in a split-second escape maneuver. This reaction is so fast, it bypasses conscious processing. Their bodies simply move before their brains fully register the threat. It's the aquatic version of dodging a bullet. This sensor-driven reflex has saved countless species from extinction. Survival underwater is a war of pressure waves, and the lateral line is both shield and sword. Fish don't just sense threats. They also use the lateral line to hunt effectively. Species like trout and bass can track prey even when visibility is near zero. They follow turbulence trails left by swimming animals. Each tail beat leaves a signature in the water. The predator reads these patterns like footprints. That trail guides them to their target, even if the prey tries to hide. It's a chase unfolding in pressure fields, not visuals. The predator sees through motion itself. This turns the lateral line into a biological tracking device. Even stationary fish benefit from this sixth sense. Bottom dwellers like flounder or stingrays stay buried in sand, waiting. They detect nearby animals through the subtle push and pull of water around them. A crab scuttling across the seabed creates microeddies, tiny ripples unnoticed by most creatures. But to these fish, it's a beacon. They strike the moment the water tells them something edible is near. No movement required, no sound needed. It's pure information collected passively from the surrounding fluid. This passive sensing saves energy and keeps them hidden. The lateral line even helps fish stabilize themselves in fast currents. Streams and rivers constantly push and pull at their bodies. Without a way to sense the water's force, they'd be tossed around helplessly. But the lateral line delivers crucial feedback. It tells the fish when to angle its fins, shift its weight, or brace against turbulence. That's how salmon swim upstream with such precision. They read the chaos of the rapids like a map of pressure gradients. Every swirling eddy contains information, and the fish use that information to fight their way home. In still water, the lateral line picks up even the slightest motion. A mosquito touching the surface creates ripples that radiate outward. A small fish feels those ripples instantly. It knows the size of the disturbance, the location, and whether it's prey worth investigating. This microscopic sensitivity is unmatched by most land animals. Imagine sensing a heartbeat across the room without touching anything. That's the scale we're talking about. The fish's world is full of signals we can't perceive. To them, everything speaks through movement. Some species have evolved extreme versions of this system. Eels, for example, rely heavily on the lateral line to navigate murky environments. Blind cavefish have such enhanced lateral line systems that they move flawlessly through pitch-black caverns. They feel walls, tunnels, and other fish through the pressure fields alone. It's a sensory replacement so powerful it beats eyesight in certain conditions. With it, they glide effortlessly around obstacles. Losing vision didn't weaken them, it reshaped them. Their entire lives now run on the language of water movement. Even aggressive species use this sense to assert dominance. Larger fish can detect when smaller fish approach their territory. They sense the direction and intensity of water displacement. A small shift can signal trespass. The dominant fish reacts before the intruder even comes into view. This prevents ambush, confusion, and unnecessary conflict. The water tells the story of every movement, and the lateral line reads it like a territorial alarm system. Underwater borders are enforced through pressure alone. Fish also use the lateral line during mating rituals. The vibrations produced during courtship displays are part of the communication. A male fish may flare its fins or shake its body to generate specific patterns. Those patterns travel directly to the female's sensory organs. She evaluates the strength, rhythm, and consistency. It's a language of motion that defines attraction. Even in murky water, these signals cut through the noise. They allow reproduction where sight-based cues would fail. Vibrations become messages of readiness and fitness. Young fish depend on the lateral line from the moment they hatch. Fry are tiny, fragile, and nearly invisible. They must avoid predators too fast and numerous to track with sight alone. The lateral line becomes their lifeline. It alerts them to sudden movements in the water. It guides them towards safety and away from turbulence. Even as they grow, this sense shapes every instinct. Their survival rate depends on reading water like a living script. This sixth sense is imprinted into their earliest behaviors. The lateral line doesn't work alone. It interfaces beautifully with the fish's brain. Sensory neurons fire rapidly, forming a detailed map of the world around them. This neural network processes spatial information in milliseconds. It identifies threats, opportunities, and obstacles in real time. That's why fish move with such fluid grace. Their reflexes are faster than ours because their sensory input is constant. For them, the world is not static. It is a dynamic pressure landscape, and they navigate it with ease born of evolution. Humans often underestimate fish intelligence because we rely so heavily on vision. We forget that other creatures experience their environment through senses we barely understand. Fish live in a realm where pressure, motion, and flow are the primary language. The lateral line lets them interpret this without conscious thought. It is automatic, omnidirectional, and incredibly precise. Seeing a predator is helpful, but feeling it from meters away is life-saving. Their world rewards perception, not just speed, and they are masters of both. This sense makes them far from simple animals. Scientists study the lateral line to inspire new technologies. Underwater robots mimic its mechanics to navigate without cameras. Drones equipped with pressure sensors can move silently through murky water. Engineers even hope to build systems that detect threats without relying on sonar. Nature's design is efficient, durable, and beautifully simple. The lateral line remains a masterpiece of biological engineering. Its seamless integration with behavior inspires innovation. Once again, fish prove to be more advanced than they appear. Their sixth sense is reshaping human technology. Even though humans lack a lateral line, we can still appreciate its brilliance. It represents an entire sensory world hidden from our experience. It's a reminder that perception is not universal, it's specialized. Fish thrive in a world built on fluid dynamics. Their abilities reflect millions of years of evolution, refining their survival toolkit. The sixth sense is not a metaphor. It is a literal sensory organ. Every move they make is informed by water's whispers, and every whisper shapes their decisions. This sense makes them extraordinary. So the next time you watch fish dart, glide, or weave through the water, remember the invisible network guiding them. They are reading pressure changes like sentences in a book. They navigate a world where touch happens from a distance. This sense reveals danger, opportunity, and direction long before their eyes do. It allows survival in the darkest depths and the murkiest shallows. It lets them communicate without sound and interact without touch. The lateral line is their secret weapon, sharp as sight and faster than thought. And through it, they feel the world with astonishing clarity. The water is alive with messages, and fish are always listening.